Okay, so you have no questions.
Nope.
Okay, so I'm going to do a share screen where you can see what I have on my tabletop. Okay, so hopefully you can see what I have here. It's just a little juice box, and if you're a parent, you know what these things are.
Yes.
So I got this at the Winco yesterday, and I'm looking at the label on the side, and I'm going to zoom in on the label specifically right here. And you can see that this has 90 milligrams of vitamin C in it, which is 100% of your daily recommended amount. Usually for children, the amount is larger than for adults. So this is probably a child's amount. And you see down here where it says ascorbic acid?
Yes.
That is the common name of vitamin C as well as vitamin C.
Oh.
Okay, so apples don't have vitamin C in them.
No.
So the apple juice had vitamin C added to it. Citric acid is sort of a preservative. It helps stabilize the ascorbic acid.
Okay.
Now, when I flip this over, you can see that this thing has 200 milliliters. And you see how this has 6.75 fluid ounces?
Yeah.
3 significant figures, right?
Right.
So this 200 also has 3 significant figures. It's 200 milliliters. So that's the first thing we're going to note about this, is that when you look at the serving size, it's 200 milliliters. Mama. So I'm going to zoom back out. And we're going to write that down just over here in the corner, that 200 milliliters of juice, so I'm using J for juice, is equal to 1 serving. And we also know that that 1 serving should equal 90 milligrams of vitamin C. So what does VC stand for?
Vitamin C.
Yeah, because I'm not going to write vitamin C out when I can write VC. Okay, so we want to see if this juice does have 90 milligrams of vitamin C. And I'm going to show you how we do this experiment. This experiment is called a titration. And a titration is when you determine the amount of a substance in a mixture. So you determine the amount of a substance in a mixture, and in chemistry, you're going to use a chemical reaction. And the reaction we're going to use is, here's vitamin C. I'm trying to remember what it looks like. This is basically vitamin C. We're going to react it with a dye that looks like this. And as far as this goes, I wouldn't bother writing this part down. I just kind of look at it. I think that's the structure of the dye. I'm going to take a quick look It's been a while since I've actually done this experiment in this class because of the coronavirus. Okay, I am missing something. And what I am missing is this. Okay, I was close. Close but no cigar. So this is the dye. It's called 2,6-dichlorophenol indolphenol. And you can
Wow,
see
that's a long word.
they call it DCP for dichloro. The di is the D, chloro is the C, and then the phenol is the P.
Gotcha.
So I just use the word dye. And the reason I use the word dye is because it's red in acidic solution.
Okay.
And it's blue in neutral solution. So not only is it a reactant in this reaction, but it's a pH indicator actually. Now, when you react the vitamin C, and I see that I have drawn the vitamin C incorrectly. I wrote down the, actually, did I write it down incorrectly? No, I didn't. I'm only missing that. So here's the vitamin C. Now, the vitamin C is colorless when you put it in solution. After you react these, the vitamin C does this thing here. And it's still colorless. But I think when you look at these two structures, it's not a far cry to say that, oh, that must have turned into that. Does that make sense?
Yeah.
It looks so similar. Now the dye turns into this. And this is colorless. So do you see how the this structure here on the left looks kind of like the one on the right?
Yeah.
And it's not a far cry to say, oh, that must have turned into that.
Right.
So this is the chemical reaction we're going to use. So in titrations, there are a number of things that you want to have happen. You want to have a well-known reaction. And so here, we know this reaction so well that we can draw out the molecules that are reacting. What's the ratio here of vitamin C on the left to vitamin C on the right, if you had to guess? How many of these to make how many of these?
Two.
How many of these are required to make how many of those?
Hold on. There we go.
Don't you think that looks like that, and it looks like one of these turns into one of those?
Yeah.
So the ratio is 1 to 1.
1 to 1. Okay.
How many of these turn into how many of these?
1 to 1.
1 to 1. So when you draw chemical formulas, structures for the molecules, a lot of times the coefficients, the numbers in front, kind of elude you. You don't write them out because you're supposed to see that, oh, one of these makes one of those.
Okay.
It's kind of obvious because if we had 2 of these make one of these, we should have 2 of these over here. Right?
Right.
or somehow two of them connected together over here, right?
Right.
And so here, when we take a look at this, it doesn't look like we cut it in half or anything. It just looks like we added a hydrogen here and added a hydrogen here. And interestingly enough, if you look at this guy, it looks like we took off a hydrogen here and a hydrogen here. And that's why there's only oxygens there. So where'd these two hydrogens go? Well, one went here and ended up like that. And one went here and ended up like that.
Okay.
Okay. So in titrations, you want to have a well-known reaction. You want to mix the reactants in a stoichiometric equivalence. So what does that mean? Well, in this reaction, we have one vitamin C react with one molecule of dye, and it gives you one vitamin C product plus one dye product. Okay, so our stoichiometric equivalence is 1-to-1. Now, if we had another reaction like this, 2HCl plus MgOH2 gives you 2H2O plus MgCl2. The stoichiometric equivalence here is 2-to-1. So do you understand what I mean by the stoichiometric equivalence?
Yeah.
I'm going to write stoic instead of the whole word, stoic equivalence. So in other words, we want to react the reactants so that every reactant molecule reacts and we have no leftovers. Does that make sense?
Yeah.
Okay. When we get that stoichiometric equivalence, it is called an equivalence point. Naturally, an equivalence point, but it's also called an end point. So that's when we know our reaction is done. So in our titration, we want to have a well-known reaction. We want to mix the reactants in a stoichiometric equivalence, and we want to be able to easily see when we have reached the end point. And remember, endpoint is just another word for stoichiometric equivalence. So the question here is, how does this reaction help us achieve all of this? Well, we already know it's a well-known reaction, but how are we going to be able to see the endpoint? So this next part is a hypothetical, okay?
Okay.
Now, if I have a solution here and it's slightly acidic, it will be clear and colorless. Okay?
Mm-hmm.
Now, if I add 1 drop of dye, which is going to be red when it hits the acid, the solution will turn pink. Now, that means we have more dye molecules than vitamin C molecules because clearly we have no vitamin C molecules, okay?
Right.
So here I have a little, I don't know what you call this, a little container. And what I'm going to do here is I'm going to put a little water in here. Whoops, I'm spilling water on my paper. So what I'm going to do here is I'm going to just take the lid off and pour a little bit of water in there. Can you see the water in there?
Yeah.
Kind of.
Kind of.
Okay, let me see if I can change my lamp. It's kind of hard to see because it is a white glass and you're looking through a colorless water, right?
Right.
Now I have this metaphosphoric acid, and what I'm going to do is I'm going to just take one of my pipettes and I'm going to draw in like a little bit and put 1, 2, 3, 4, 5 drops in. So this metaphosphoric acid is going to make this acidic. Now I've made a mistake. I should be wearing my goggles because of the acid. Okay, so this is water with acid in it. And I'm going to write a little legend here, water with acid. And this is just going to be water. So can you see the labels below?
Yeah.
Now I don't have much dye left because I was trying to work out this experiment last night. So this is the dye. It's called dichlorophenol indolphenol. And it's a very dilute solution. I'm going to take a little bit of my dye. Do you see how it's blue colored?
Yeah.
Now watch what happens when I add it to my water. Do you see how it starts to spread out and it turns the water slightly blue?
Yeah.
If I'd used less water, it'd be more noticeable. But I think when you look at these two colors, you can definitely see that this one on the right is blue and this one on the left is no color. Now, watch what happens when I take 1 drop of this dye and put it in the left container. Do you see how when it hits, it turns pink right away?
Yeah.
That's the acid-base reaction. And you see how it's slightly tinged pink?
Yeah.
Now, just to make sure that we know it's slightly tinged pink, I'm going to put another one of these here, and I'm going to put just pure water in it. So we can see that this is water. This is water with no acid in it and with 1 drop of dye, and this is water with acid in it, 1 drop of dye. So now I'm going to show you another interesting thing here. I'm going to go ahead and add a little bit of acid to this container. And I'm going to take a little bit of my ascorbic acid and put it in here. You can barely see the specks there, right?
Right.
So it's in there now. Okay, now previously, when I had water and I added a drop to this, I'm going to pour a little bit of this out. So when I added a drop of dye to this, it turned it pink, right?
Right.
Well, let's see what happens here. Do you see how it's starting to turn pink in the middle? There's some blue starting to turn pink.
Yeah.
But look what happens now. There's no color. Here I added 1 drop of dye. It turned pink. Here I added 1 drop of dye. Nothing. Why is that? Well, I'm going to use a drawing that we have to explain to you why that is the case. So in this one container right here, I have vitamin C and water. And when I add a drop of dye to it, the dye reacts with the vitamin C and becomes colorless. So the reason this is colorless is because the dye has reacted and become a colorless form of the dye. So again, This is water with acid and a drop of dye. On the left, we have water, vitamin C, and acid, and a drop of dye, and it's colorless. And the reason this is the way it is because the dye has changed to colorless. Okay, so I'm going to draw what happened in the second situation. We had acid, we have water, and we have vitamin C. And then we had 1 drop of dye. And what happens is we still have acid, we still have water. Some of the vitamin C has turned into vitamin C product. Some of it, but not all of it. And what has happened to the dye that we dropped in? Well, the dye has turned into dye product, which is colorless. So all of the dye has reacted, and that's why it's colorless. Now, if only some of the vitamin C has reacted, but all of the dye has reacted, have we reached a stoichiometric equivalence? And the answer is no. Our stoichiometric equivalence should be when all of the vitamin C has reacted and all of the dye has reacted. Does that make sense? And here, all of the dye has reacted, only some of the vitamin C has reacted, but we're not at an equivalence. So what we do is we keep adding drops of dye. Now, eventually, we're going to get really close to an equivalence. And when you add just a little bit more dye, what's going to happen? It'll turn pink because you'll have vitamin C product, you'll have dye product, which is colorless, but you'll have just a little bit of unreacted dye. And that little bit of unreacted dye makes this pink. And we call that the equivalence point. Now, the amount of extra dye in there is really inconsequential. So this is the end point right here. Okay, so now I'm going to show you the steps for doing the lab. I'm going to go back and forth between the lab write-up on Canvas and here so you can see what's going on, okay?
Okay.
I'm leaving my goggles on because I'm going to be working with acid in just a moment. So I'm going to change my share and I'm going to go to the procedure. I think that's the one I want. Okay, do you see the procedure?
Yeah.
Okay, so to do this, we have to make a solution of vitamin C where we know the concentration. And the reason for that is we're going to take that solution and test it with our dye and see how much dye it takes to react with this solution. So you're going to want your balance. So here's my balance. And you're going to want a piece of paper to weigh your vitamin C on. So here, if you can see, I've got a thing that I got from Ace Hardware. So it's a little flyer that wants me to buy something at their store. So can you see that?
Yeah.
I took off a little square and I'm going to fold it in two. And that little groove there is going to be my funnel for pouring the vitamin C into my graduated cylinder. Okay, so I need to grab my graduated cylinder. I'll be right back. So here's my graduated cylinder. And it is not dry, but I don't care that it's not dry because I'm going to add water to it and measure the final volume. So if there's already water in it, that'll just be part of the final volume. I'm okay with that. So are you looking at the procedure or my balance right now?
The procedure.
Okay, let's look at my balance. Notice the procedure says weigh about 125 milligrams of ascorbic acid and place it in the cylinder. Let's do a little bit of work here and find out how many grams that is, okay?
Okay.
So we have 125 milligrams of vitamin C, and we want to convert that to grams of vitamin C because my balance measures in grams, not milligrams. So one way to do that is to simply do this. 125 milligrams of VC is equal to 125 times 10 to the minus 3 grams of VC. So here, this method is called substitution. I am substituting 10 to the minus 3 for milli. And when we multiply that 10 to the minus 3 times all this, we get 0.125 grams of vitamin C. Another way to do it is to take the 125 milligrams of vitamin C and multiply by 1 gram of vitamin C over 1,000 milligrams of vitamin C. And again, we get 0.125 grams of vitamin C. This way of doing it is called a conversion factor. So the important thing here is that I need 0.125 grams. So here's my balance again. I'm going to put the piece of paper on here before I turn it on. And that way, when the balance comes up to spec, it says 0 grams. So it thinks that the paper is not there. Now I'm going to take my vitamin C and I'm going to take my micro spatula, the thing that I call the canoe paddle for rats, and we're going to put some vitamin C on the paper. So here you can see how much I'm using. It's like a size of a small pea. Oh, look at that. I got 0.12 grams. Now I'm shooting for 0.125, but I can't read a number beyond the second decimal. So I'm going to go with 0.12. And I'm going to use that little funnel to pour this into my graduated cylinder. Now, a little bit of vitamin C is getting stuck on the sides of the graduated cylinder. You can see it, a little bit of it stuck right there. And what I'm going to do is I'm going to add some water from my water bottle to wash it down. So I'm actually squirting the sides and squirting that vitamin C down into the graduated cylinder. And I'm making a mess. I'm glad I brought out a paper towel, or I should say a little hand towel. Okay, and here, if you take a look at my graduated cylinder and you look down the middle of it, do you see how it looks cloudy?
Yeah.
That's because the vitamin C hasn't dissolved. So I'm going to help it to dissolve by stirring it. And you see how it's still cloudy?
Yeah.
So I'm going to do it again. And it's still cloudy. It's going to take more than the water I put in there so far to dissolve it. Now I'm going to do a change share so that we can look at the directions again. So this says dissolve it in about 50 milliliters of water. So what I'm going to do is I'm going to add a little bit of water each time, swirl it, and hopefully that vitamin C dissolves, okay? Now, when I say hopefully, when the directions say take 125 milligrams and make it about 50 milliliters of solution, you know it's going to dissolve. So I'm going to keep adding water little by little, helping it to dissolve until I get around 50 milliliters. Now, when I'm doing this, I'm not going to take any special care to get 50 milliliters exactly. That's not the point. The point is to get around 50 milliliters. And I'm looking at this, and when you see this, I'm going to do another change share. Okay, so can you see?
I just see you. I think you.
Good.
Oh.
That's what I wanted.
Okay.
You see how that is above 50?
Yeah.
That's okay.
Okay.
That's okay. So here, for step one, I'm going to go back to the procedure now. There's going to be a lot of me going back and forth. And if I'm discussing something that doesn't seem to be on the screen, you need to say something, okay?
Okay.
So for the first step where I say VC solution, I have 0.12 grams of vitamin C, and that's going to be equal to my 50, I'm going to put XY milliliters of vitamin C solution.
Am I supposed to be looking at what you're writing down or the procedure again?
Well, we're looking at the procedure.
Okay.
And you see how this, it says, this is your first equivalence.
Right.
X milligrams of vitamin C equals Y milliliters of vitamin C solution.
Right.
X should be around 125 milligrams. And I have 0.12 grams, and Y should be around 50 milliliters. Now I'm going to share with you what I have written. So I have 0.12 grams. I'm going to do this. I'm going to multiply by 1,000 milligrams per 1 gram. And then this ends up being 120 milligrams of vitamin C. So for my number one, I have 120 milligrams of vitamin C is equal to, and I'm just going to invent a number, 52.2 milliliters of solution. I didn't actually look at it, so I just made this up, okay?
Okay.
But when I showed it to you, it was clearly over 50, right?
Right.
Okay, so that's number one. And I actually should write, I'm going to cross this out, 120 milligrams of vitamin C is equal to 52.2 milliliters of vitamin C solution. So here I want to tell everyone what kind of solution it is. So that's number one. Now, this is all stuff you're going to be doing at home for yourself.
Right.
Now, what are you going to do next? So here I have my vitamin C solution, and you want to make sure it's mixed well. So here I have my 100 milliliter beaker and my 50 milliliters of solution. And to make sure that this is mixed well, I'm going to pour this into my beaker. You want to make sure the beaker is dry and clean. I'm going to pour this back into here. And the idea is that when I pour it back into here, if there's any residue of vitamin C on the bottom, pouring it back in will help dissolve it. Does that make sense?
Yeah.
So this means that we can avoid finding some long stick to put in here and stir it. Okay, so now I have my graduated cylinder empty and I have my solution in here. And remember, this solution is 120 milligrams of vitamin C in 52.2 milliliters. Okay.
Right.
Now, I happen to have a pipette that's wet, and I don't know what's in there. But I do know that if it's not the same as this, it's going to change this.
Right.
So, but I still want to use this pipette. I really want to use this pipette. So here's what I'm going to do. I'm going to squeeze the bulb, and I'm going to pull up some of the solution. And you see how I'm getting a solution in my pipette?
Yeah.
So now I'm going to rinse my pipette out, and I'm going to put this in a container where I have used solution. And I'm going to do that again. 2, 3. So this is akin to using a cup, and when you're done with it, you rinse it out 3 times with water.
Okay.
So I've just rinsed out my pipette 3 times with this solution. So if there's anything left in there, what is it?
The same as the solution.
It's the same as the solution, which is perfect. Chemists do this all the time instead of cleaning glassware. Rinse 3 times and you're good to go. I knew some guys when I was growing up in college who would wash their dishes that way. Rinse it 3 times. If it doesn't come off after 3 rinses, it won't. It's good to go next time. Probably not the best way to do things.
No, probably not.
Okay, so the next part, I'm going to use my graduated cylinder again, but it has this solution in it, right?
Right.
I want to get that solution out. So I'm going to use my water bottle, and I'm going to squirt some water down the sides, and I'm going to rinse that out like I did my pipette 3 times. And the most important thing is to try and squirt the sides down. I mean, if you wanted to, you could do this in the sink, fill it up all the way and then pour it out. But I'm not by a sink, so I'm just filling it up with about 5 mils and then rinsing it out. Okay, so now my graduated cylinder is rinsed out, and the only thing in there is water. So I'm going to go to step 2, and then I'm going to show you how to do it. So I'm going to change my share screen to the directions. And you see step 2 says DVC solution.
Yeah.
D stands for dilute. So we're going to take that original solution and we're going to dilute it. And the reason we dilute it is because it's too concentrated for our dye. If we use this solution we just made with our dye, we will run out of dye and we will not be able to complete the experiment.
Okay.
So how do we dilute it? The directions say rinse a pipette, which I just showed you how to do, and transfer precisely 1 mil of the solution to your cylinder. Cylinder does not have to be dry. Now, here's my pipette. I'm going to change my share. I'm not going to do it quite yet. So it says 1 mil. Then it says add about 10 mils of metaphosphoric acid to the cylinder. About means it could be 7 mils, whatever, around 10. 7 rounds up to 10, right? Okay. And then add enough water so that you have almost 100 mils, but not 100 mils total.
Okay.
With me?
Yeah.
Okay, so I'm going to show you now what I'm going to do. I'm going to do a different share so you can see what I'm doing here. Okay, so here's my graduated cylinder that's empty. Here's my solution I just made, and here's my pipette. Now let's look at this pipette here. I'm going to zoom in on it. Okay. Do you see these little lines that go around the pipette?
Yeah.
Let me see. I may have one that's drier. This one's drier and it's easier to see. So do you see the little lines here?
Yeah.
This is the first line right here. This is the second line right here. And do you see on this second line, it actually says 0.5?
Yeah.
Here's the third line. And then here's the fourth line that is right beneath the bulb. And you see how it says 1.
Right.
So that's 1.0 milliliters. This is 0.5. So what would your guess be for this line right here?
0.75.
That's right. Okay. So to transfer 1 milliliter to my graduated cylinder, I'm going to zoom back out now. So hopefully you can see what I'm doing. Okay, so here's my graduated cylinder. Here's my solution. I'm going to fill this to that line. Okay, so here it's filled to the line. Can you see
Yeah.
to the line? And I'm going to put it in my graduated cylinder. So I have just put 1 milliliter of this solution into here.
Okay.
Okay, so now I'm going to set that solution off to the side. Here is my acid. And I'm going to pour acid into here. Now, you don't want to pour all of it in here because you need to use this acid twice.
Okay.
So now I have acid in here. And now I'm going to add water. Until I have close to 100. I'm going to do a change share here, actually a stop share. So can you see the water in my graduated cylinder?
Yeah.
Now, right here where I'm pointing to, that's 100. This is 90, and the level is not quite 100.
Right.
Don't bother trying to get 100. Get close to 100 and write the number down.
Okay.
So I'm going to do a different change share. And for number 2, this is what we would write. We'd write 1.0 milliliters of vitamin C solution, because that's how much we measured, right?
Right.
Is equal to, and I'm going to invent a number, 97.2 milliliters of DVC solution. What does DVC mean?
Diluted vitamin C solution.
Right. Now, you see this solution here? My diluted vitamin C solution?
Yeah.
It's not mixed very well. I guarantee it. So here I have this Erlenmeyer flask, which I know can hold all of this in there. And I'm going to pour this in. And how am I going to mix this?
By pouring it right back.
Yeah, this is almost like, feels like a kid's experiment, doesn't it?
A little bit.
We're going to work with pipettes and cups and oh my. So I'm going to do that. Okay. So guess what I'm going to do with my graduated cylinder now? Rinse it out.
Yeah.
And put the solution in my little container for all the used solutions. And that way I know it's ready to go for next time.
Right.
Okay, so here is my dilute vitamin C solution. Now, here's the pipette I'm going to use, and it's got liquid in there. So what am I going to do?
You're going to rinse it out 3 times with the solution.
That's right. And I'm going to dump that into my big old coffee cup where I'm collecting everything. Okay, and that's rinsed. So I put the pipette back in there. Okay, so that's number 2. Any questions about that, number 2?
No.
Now, does that look like it could be used to convert?
Yes.
Yeah, because we're used to seeing 12 inches equals 1 foot or something like
Right.
that. So this could be used to convert, where we could put one of these on top and the other on the bottom, depending on what we want on top and what we want on the bottom and what we want to cancel. Fair enough?
Yeah.
Okay. So now I'm going to change back to the directions. And we're going to go to number 2. Do you see the bottom? This is your second equivalence. It will be 1 milliliter of vitamin C equals Z milliliters of dilute vitamin C.
Yeah.
And the number I invented was 97.2 milliliters. Z is close to, but less than 100 mils. Fair enough?
Yeah.
Now, number 3 is titrating the DVC solution. So it says rinse another plastic pipette with the DVC solution 3 times. We've done that. And this says transfer 2 mils of the DVC solution to a container. And here, this is where I say, I like to use a white container. So here, I'm going to do a change share so you can see the container I'm going to use. It's this one right here. And can you see how that's slightly blue on the inside?
Yeah.
So what I'm going to do is I'm going to dump that into my container where I'm collecting everything. I'm going to rinse this out 3 times and get rid of anything that was in there before. And there it's rinsed out. And can you see that there's nothing in there?
Right.
It's a little wet. Now, remember, this is the solution we had for pink. Do you remember that solution I made where I took a drop of dye and put it into acid and water?
Right.
So there's my pink color. Now, here is my diluted vitamin C solution. I'm going to take 2 mils and put it in here. So you remember how to get 1 mil, right?
Right.
So how do you get 2 mils?
Do the same thing, but twice.
There you go. I do get some people asking me, well, how do I do 2? Well, do 1 twice.
Right.
Okay, so there's my 2 mils. And do you see how there's not even enough liquid to go to the edges of the container?
Right.
I'm okay with that. Okay, so I got my 2 mils, and here I have my nice comparison. And now I'm looking for my dye. Here's my dye solution. And here's my pipette. Now, this pipette, I'm pretty certain I used with my dye solution because it's got blue on the inside.
Right.
So I'm not going to rinse this one out.
Okay.
Since you have so little dye, you never want to rinse it out.
Right.
So use a nice, clean, dry pipette for your dye. And I'm going to add drops. So here's 1. Do you see how that turns pink?
Right.
Now I'm going to swirl it. And now there's no color. 2. Three. It's always amazing to see all that color, and then I swirl it.
And it runs away.
And it's gone. It's gone because all of the dye is reacting. So that means we haven't reached the end point yet. So the end point will be when we add a drop of dye and the color stays pink.
Okay.
So I've lost count.
I think that was 4.
And what you don't want to do is lose count.
Well, then it's a good thing I was counting.
Now that last time I swirled it, the color seemed to stay a little longer. So that must mean I'm close.
Right.
And look at that. That looks like it's almost there. Do you see how if I tilt the container, I can put it all in one little kind of corner
Yeah.
and it's easier to see the color. So let's try another drop. And you see how one drop made that turn pink and stay pink very well.
Yeah.
One extra drop. So I didn't count the drops kind of on purpose. It looked like it took about 7 or 8, I think. I don't remember. You could always rewind the video and count them. But you see how the colors.
I was counting. You had 8.
Okay. So do you see the color matches?
Yeah.
So that would be number 3. Number 3 would be 2.0 milliliters of dilute vitamin C solution equals 8 drops of dye. Now, why might you require more drops of dye or less drops of dye? And the answer is maybe you don't make 97 milliliters. Maybe you make a little more, a little less, and that could change the number of drops.
Right.
Okay. So do you understand number 3? I'm going to go back to the share where we can look at the directions. And at the bottom of number 3, do you see what it says? This is the third equivalence.
Right.
2.0 milliliters of DVC solution equals A drops of dye. In this case, it looks like it's 8.
Okay.
Okay, so I'm going to write something on my paper here to share with you. So number 1, we had 120 milligrams.
I'm still looking at the procedure.
Thank you. And that's why I asked people to let me know, because it's so hard to keep track of all of this.
Right.
So number 1 was 120 milligrams of vitamin C is equal to 52.2 milliliters of VC solution. And number 2 is 1 milliliter of vitamin C solution is equal to 20, so forth and so on, right?
Right.
And do you see how we could do this? We could say 120 milligrams of vitamin C over 52.2 milliliters of VC solution. We could start there, right?
Right.
And then I could multiply by 1.0 milliliter of VC solution over 97.2 milliliters of DVC solution. And I see I screwed up. No, I didn't screw up. I'm okay. Do you see how milliliters of vitamin C cancels with milliliters of vitamin C on top?
Yeah.
Now, if I were to use this next one, what would I write?
The 2.0 milliliters of DVC solution over 8 drops.
And here, I'm going to do something. I want to write 8 drops of dye. And here, I'm just going to leave that like that. And you see how the milliliters of DVC solution cancel out. And right now, I would have 120 milligrams of VC over drops of dye. Basically, if I calculated this number, it would tell me how many milligrams of vitamin C 1 drop of dye reacts with.
Okay. Yeah.
So that drop of dye, if you will, is like a tool to measure with. Let's actually calculate this number here. Should be pretty small. And I get 0.0059 milligrams of vitamin C per 1 drop of dye. Do you get a similar number?
Yeah.
Okay. So that dye does not react with very much vitamin C. And that's why we have to dilute our vitamin C solution to conserve the dye.
Right.
Okay, so that's number 3. We don't actually do this calculation, but I just want to show you that we could do that.
Okay.
Okay, now I'm going to change my share to the directions. And hopefully I can show you number 4. So number 4 says DJ solution. What do you think DJ stands for?
Diluted juice.
That's right. So
Yeah.
here's my juice box. And I'm going to show you how to dilute the juice box. Now remember, I've already cleaned this out, so it's ready to go. This says to take 2 mils of the juice, put it in the cylinder with acid, and then add enough water to get close to 100, but not 100 completely.
Right.
Okay, so I'm going to do my change share so that you can see what I'm doing with all of these things. Okay, so I'm going to use this pipette with my juice, and it's wet on the inside. So what am I going to do?
You're gonna rinse it out 3 times with the juice.
Right, so I'm going to go ahead and stick the tip right into that little slot where the straw normally goes. And I'm going to pull some juice into the bulb. I don't know if you can see that.
Yeah.
And I'm going to rinse that out 3 times. 1, 2, 3. Okay, so now it says transfer 2 mils into here, and you know how to do that, right?
Right.
So there's 1. And there's 2. And then since I use this pipette in my juice box, it's probably not a good idea to drink from that juice box.
No, probably not.
But if you wanted to drink the rest of the juice, what you would do is take that juice, pour a little bit into a clean container, and then rinse from that container. And don't drink that juice.
Right.
But drink the rest from the box. Because your kids, if they see you doing this, they're going to be like, but Mom.
They're gonna want that juice box. They always do.
Well, so you just take a little bit and squirt it into a little cup, and you only need 2 mils. It's not very much. Plus the rinses makes it about 10 mils. You just need a little bit. Okay, now, guess what I'm going to do? I'm going to add another portion of acid, about 10 mils. Okay. And now I've used up all my acid. And now I'm going to add water until I get close to 100 mils. And I'm going to write that value down. So here, I'm going to say that that's, I don't know, 97 milliliters. So I've got 2.0 milliliters of juice is equal to 97. I'm going to use the same number again.
All
Actually,
right.
I'm going to make it 98.2 so that we can see it's different. And let's make it 98.8 so it looks really different. So this is 98.8 milliliters of dilute juice. Now, what do I have to do with my dilute juice that's in my cylinder?
Mix it.
Mix it. So I have this container here that happens to be pretty handy. You got to be careful though, because it's pretty full. Okay, so if I use the same pipette that I used for the juice in this container, what do I want to do with this pipette?
Rinse it 3 times with the solution.
And I want to make sure no juice comes out of it. So I'm going to squeeze the bulb beforehand, put it in here, and then that way it just sucks stuff right into it. If you wanted to, you could also pre-rinse these with water and then rinse them with the solution 3 times. And that's probably not a horrible idea.
Okay.
Okay, so now I've got my new solution, which is my diluted juice solution. Now let's go to the directions. So number 5 says titration of the dilute juice solution. Rinse the pipette 3 times, blah, 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 blah. Transfer 2 mils to a container. So I'm going to rinse this out because I don't know what's in it. Okay, so this is clean. It's not dry. And I'm going to put 2 mils into this container, and I'm going to show you that by switching screens here in just a moment, okay?
Okay.
So this is my diluted juice solution. This is my clean container. It's not dry, but doesn't matter. I'm going to take 2 mils out of this. 1. 2. So there's my 2 mils. And what am I going to do to this?
Add the dye.
Add the dye until it turns pink like this one.
Right.
Now, where is my, oh, there it is. It's always easy to spot the dye pipette because it's got blue on the inside. So I'm going to cover it up so you don't know how many drops I'm adding. I will show you the first drop. Do you see how it's turned pink?
Yeah.
And then colorless. So I'm going to hold this off to the side so you don't know how many drops it takes. Now, a real chemist, when they're adding the drops in, they'll swirl it at the same time. So you're swirling and putting drops in.
Okay.
Which seems hard, right?
No, not really.
It's 2 different things, right?
If you can pat your head while you rub your tummy, you're good.
But the real test is, can you pat your tummy and rub your head? Give it a shot. Pat your tummy and rub your head.
Pat your tummy
and rub your head.
Look it.
So I'm going to show you the trick to getting it right every time. So pat your tummy, rub your head. Start with rubbing your head first, then pat your tummy. Don't try and do both at the same time. Start one, then the other, and it's a piece of cake.
Right.
So I like to swirl and then add drops.
Okay.
See, I bet you're wishing you knew this trick back in kindergarten, because then you could have done it right every time.
Right?
Okay, so here, do you see how it's not quite pink yet?
Yeah.
But the reason I showed it to you is because the last drop I added in, it seemed to stay red longer before it disappeared. And that one stayed a long time. But you see how it's not quite pink yet?
Yeah.
So I'm betting that the next drop does it. What do you think? Is it pink?
It's pink.
So you see, just one drop of dye is going to make the change that you want. Okay, so for number 5, I used 2.0 milliliters of dilute juice, right?
Right.
And that's equal to X drops of dye. And you don't know what X is because I did it off screen.
Right.
Right? Number 6. So number 6 says the 6 equivalents. This is the volume of one serving in milliliters. So we have 200 milliliters of J is equal to 1 serving. And I'm going to show you what I had just written down so you can see that. Now, what if you don't get the same juice box that I have? You might have a different number here.
Right.
Okay, so if you take a look at this, we can write 120 milligrams of vitamin C per 52.2 milliliters of VC solution times 1.0 milliliters of VC solution per 97.2 milliliters of DVC solution times 2.0 milliliters of DVC solution per 8 drops of dye. Now, what do I want to use next? Let's see what cancels out. Oh, that doesn't cancel out. I got to rewrite that. Milliliters of VC solution cancels. Milliliters of DVC solution cancels. I got to cancel drops of dye. What am I going to use?
We're going to use 1 drop of dye over 0.0059 milligrams of VC. Oh,
Nope.
nope.
We're going to use that.
That one.
X drops of dye
Over
per
2.0
2.0 milliliters of dilute juice. So drops of dye cancel. What goes next?
Number 4.
So we want to put this 98 on top, right?
Right.
What goes next?
The 200 milligrams, or number 6, 200 milligrams of juice equals 1 serving.
Milliliters.
Milliliters.
Okay, so that will cancel, and we're going to get milligrams of vitamin C per serving.
Right.
And what should the answer be? According to this juice box, it should be 90.
Right.
So let's see what we get here. $120 times 2. I'm not going to bother multiplying by 1 because that's not going to do anything. I can't do anything about X. Times 98.8 times 200 divided by 52.2 divided by 97.2 divided by 8 divided by 2 and divided by 2. Now, with all the numbers I've used so far, I can kind of estimate the answer, right? Because what's 98.8 divided by 97.2?
About a little over 1.
Let's call it 1. What's 2 divided by 2?
1.
So what's 2 into 200?
10. No.
100.
100.
Okay, so we've used
Zero.
all of this stuff and we have 100 on top. How many times does 8 go into 100? Actually, how many times does 52.2 go into 100?
Almost 2.
So we'll call it 2. So now we have 2 divided by 8 times 120. What's 2 divided by 8?
4.
So 4 on the bottom. How many times does 4 go into 120?
30.
Okay. So if X were 3 drops, we'd end up with like 90 milligrams. But at any rate, we know that we should get around 30 for our answer, right?
Right.
And we get 29.2. Woo! That's some darn good estimating, right? So here we only have 2 zig figs, so we're going to call it 29 times X milligrams of vitamin C per 1 serving. What is X?
The drops.
The number of drops it took for that dilute
Reaction.
juice titration. Now, how can we improve upon this experiment?
Change how much solution we use to how many drops.
I'm actually thinking, wouldn't it be better to do this multiple times to see if we're consistent?
That too.
That's the first thing you would do, is try and do it multiple times, because you know the dilute juice solution? When you titrate the dilute juice solution and you use 2 mils, if it takes you 5 drops one time, 10 drops another time, and 20 another time, that's not consistent.
Right.
And it's the same
There's
with
a
the
problem.
dilute vitamin C solution. You said it took 8 drops, right?
Yeah.
So if it took 8 drops one time, 16 another, and 52 another, that's not consistent.
Right.
So one of the things that you would do normally with this reaction is repeat it. Since we're doing this online, I'm not going to make you repeat it. I'm just asking you to do it the first time carefully. And by showing you all of the steps and all of the numbers that you're kind of going to get, hopefully you will avoid any pitfalls and be able to get some numbers to work with.
Okay.
I'm going to let you go in just a moment, but I do want to show you the rest of the lab. It says if you have time, you can try each titration 2 times, but it's not required. Everything gets poured down the sink. Collect the relevant data from the procedure. Use all of your equivalencies and calculate the milligrams of vitamin C per serving for your juice, and then compare the value to that on the juice box and calculate a percent error. I'm going to let you look up how to calculate percent error, okay?
Okay.
The result, of course, is the milligrams of vitamin C you get per serving. And then for your discussion, you discuss how your results look compared to what the juice box says.
Okay.
And you discuss why it may be different. And then you might want to put down here reasons why it may be different. And it may be that, you know, we only did it once. So are there any questions about this lab?
Nope.
Kind of an interesting lab, don't you think?
Yes.
We're going to find out how much vitamin C is in there. I'm going to give you one caveat now. When you go out and get a container of juice, make sure it has vitamin C in it, because apple juice normally does not.
Okay.
So they added vitamin C to this on purpose so that people could get vitamin C from it.
Okay. It is written down.
Okay, well, thanks for attending. I felt like we had a good run for this one.
Thank you for your time.
Yeah, and hopefully the lab goes pretty well.
I'm hoping so. Pretty sure
All
it will. Thank you.
Yeah, I think you actually said that this is one where the container opened a little bit.
It
your
might
box?
have been.
Yeah, as long as you have some dye in there, you can see that it's not going to take you too much dye to do a couple of titrations.
Right.
So you
Yeah, it
should be
wasn't the
okay.
dye that opened. It was one of the clear.
Okay, that would be the acid. So you rinse that off and it should be okay now.
Okay, perfect.
Just make sure that when you make your dilutions, you use half the acid for one dilution, half for the other.
Right.
And that's it.
Awesome. Thank you.
Have a good one. Bye-bye.
Bye.